go to design and quick layout. And that's my quick layout. It's my favorite one. You know, it's the chart title, all this stuff. I think I'll show this again real quick. All these options, you got so many cool things. It's so nice.
Gary! I was just looking for the sports channel, Gary.
Hey everybody, it is time for another office hours. Let's work on some chapter 4. I think people wanted chapter 4, right? If you're here and you want to work on something, let me get Mewbot awake. Mewbot, wake up. Sign into my course. Pearson. Oh, I'm already signed in. Look at that. Signed in, ready to go. Signed in. Trying to quit the Red Bull. I'm trying to quit it. I'm trying to stop the Red Bull. It's good to stop Red Bull, right? That's what we try to do. Oh, we got this. Chapter 4. There's only 5 questions. Look at this. Chapter 4. Okay, let's go check it out. Chapter 4, just 5 easy questions. And chapter 4 is all about box plots. So stay at 201, chapter 4, question 1, or homework. Chapter 4 homework. Question 1. So let's think about this. We need to look at these box plots and figure out what's going on with them. Okay, we got some monster men here. These are left skew monster men. And the left skew monster men, let's take a look at them. There's monster man, left skew. That's not a tooth. There's a tooth. There's monster man, left skew, left to the low, right to the high, whatever way the tail goes. That's how you tell the skewness. So a little bit of a left skew on these monster men. What else we got going on right here? The median is higher for the domestic. Median is lower. And these are side-by-side histograms. So there's higher median for the domestic and more spread. And seen everywhere. So typically domestic is higher with a greater spread. And the way I'm seeing this is, well, we don't have that data on the screen. Domestic is higher with a greater spread. Lots of measures show that. So taking a look at domestic, which is right here, it has the higher median, and it also has the higher IQR and standard deviation. Every metric of central tendency is higher compared to this one right here, which has less spread. And you can kind of see it where the spread is that versus the spread is this. And these are the same scales, which is another thing we need to do. We always need to use the same scales when looking at data. So what do they want us to do? Both distributions are unimodal and skewed to the left, so it's one of these two. The IQRs show that the international, or no, domestic is the one with the bigger, right? Domestic, the IQR is bigger. So the domestic has a bigger variation in it. Well, that was easy. Well, look at that. That's, now we get an actual box plot. We get a box and whisker plot right here. Chapter 4, homework. Question 2. So we have a box and whisker plot here with an electric car getting crazy economy captured. Yeah, which one do you want to do on the quiz? We could, have you already done the homework? Nice job. Give me a quiz question, dude. Let's do it. Thank you, Charlie. Good to see you here. Swing by. And sorry for the no in person today. Trying to figure out the schedule. We're almost stabilized. We're almost done with meetings. We got a box plot right here showing us the min, which is down here. The Q1, which is there. The median, which is here. Sugar is the main ingredient. We'll find that one here. There's that. And then the max, which is all the way over there. So the max is a huge outlier for the electric car. How will removing the outlier affect the standard deviation? Standard deviation is impacted by the mean, and so it will vastly impact it because the standard deviation is how much things deviate from the mean. So an outlier drastically impacts the standard deviation. If we look at the standard deviation formula, the standard deviation formula is computed by observations differences from the mean. I'll show it here on the screen. A little nice picture someone has of it. kind of just in summary, you would look at how far each of these observations are away from the mean, which is this part of the formula. And then you are going to sum up those differences and divide by n-1 for sample standard deviation. And with that, you're going to see a typical distance it is away. So if something's a big outlier over here, it's going to increase standard deviation. So removing it would decrease the standard deviation. Since the deviation is calculated by summing the squared differences, I think so. I think there's a trick on one of these. Wait, since the deviation is calculated by summing the squared differences. That should be right. How will it affect the IQR? Well, the IQR exists for a reason. And we'll do the sugar as main ingredient next. The IQR exists because it is not impacted by outliers. The IQR is the middle 50%. So if you have data values, something like, let's go here with a blue, like 1, 2, 3, 5, and then you have 100, the IQR is going to be something about like from here to here. So if this is the IQR, you'll notice the outlier is not impacting it much, or maybe the IQR is more like that. The outlier removal is not really going to impact the IQR. It's going to change where positions are at. Like now the IQR might be something more like the middle 50%. Well, actually, it's right there. There's the IQR. You need to average it, but notice the outliers do not impact the IQR because they're on the edges of the data. So the IQR will not vary much because outliers are going to impact standard deviation and mean. Outliers do not impact a median in IQR. That's why we use them when there is outliers. Sugar is a major ingredient. Okay, let's go do it. That was question 2. Drop another one, Charlie, if you have it. Sugar is a major ingredient. Oh, I'm getting white label error. Well, that's great. Is your thing working for you, Charlie? Well, that's great. Oh, I'm reloading. Oh, okay, reloaded. It's working. Mine's working now, too. Sugar is a major ingredient. I know this one. I've heard it. Sugar. Great job. I feel like because chapter 3 is coming up here due soon, but you're ahead. Sugar is a major ingredient. Is it this one right here? A study reports load factors. Oh, we got a bunch. Let's do it. Is it this one right here? Just type a yes in the chat if it's this one. Remember, if you want your questions done, just swing by office hours. We'll get them done. So 813 stat 201. Nice. Chapter 4 quiz. Sugar is a major ingredient. Okay. So side-by-side box plots are the visualization of two variables, categorical and quantitative. You can see right here, side-by-side box plots are a quantitative y and a categorical x, which you can see right here. Nice job, Charles. Got a bunch. We like it. You can see right here the quantitative y and the categorical x. So Charlie, what is the range of this data? They give you some numbers of reference. Here's the quantitative y and the categorical x for adult and children's cereal. What is the range of this data? What is the range of it? What is the range of the data? I give you the min and the max. The min is this adult cereal that has 1 gram of sugar. Hey, Ty, good to see you right there. Not quite 29. The range of the full data. Now, this one box might be 29. But what's the range of the full data set? What is the range of the full data set? Any thoughts? 62. 63 minus 1 is 62. And the shape of this data over here is very, very bimodal. There's 2 peaks. You can see here peak 1, peak 2. So we have bimodal data. Bimodal data. We just look here and see the bimodality of it. So peak 1, peak 2, bimodal. And now let's see what else we ask. What might explain this? Well, some children's cereal and some adult cereal are more sugary and less sugary. So cereals are either very high sugar or low sugar. Are all children's cereals higher than adult cereals? Yes or no? Type yes or no in the chat. Are all children's cereals higher than adults? Is every single children's cereal, like all of these, are they all higher than adult cereals? Yes or no? Here's adult cereals. Are all of those ones in yellow higher? Hey, Leah, good to see you there. Yes, you're right, because you can see this is the lowest children's cereal, and it's higher than that. So every single child cereal is higher. That is a yes. And then right here, a little bit in depth, which of these has a bigger IQR? Children's or adults? Type C or A in the chat. Which of these has a bigger IQR? C or A? Which of these has a bigger IQR? There's an IQR. There's an IQR. Which else has a bigger IQR? Here's the ranges. There's the range. There's the range. Yeah, definitely. Well, yes, it does. It does. It's correct. The adults have a bigger IQR than the children's, showing more variability. Exactly. Sorry, Charlie, I overthought it. So the adults has more variability in their IQR, which is a measure of spread compared to children's. They both have similar ranges. So although the ranges appear to be similar for both groups, the IQR is bigger for the adult group. There we go. Another question done. And let us know another question. I can probably do that tomorrow, Leah. How's that sound if I knock that, like, get it done tomorrow? Does that sound good? In a way, Boxplots are. The next one is in a way, Boxplots are. So 11:43, stamp 201, chapter 4, quiz. In a way, Boxplots are. In a way, Boxplots are. It's like in a way. I think it's like number 5. Nope. You're welcome. That'd be awesome. If you see it, let me know. Like, wait, Brian. Those ones drive me crazy. Oh, it's at the start. In a way. Here we are. In a way, boxplots are kind of like are the opposite of histograms. Boxplots hide key features of a distribution. Boxplots hide key features of a distribution that histograms show, like shape. Explain how you could tell by looking at a box plot where the tallest bins are. So, a box plot is designed to show us the what. Really good note that you need to know. A box plot is designed to show us the what. What's the point of a box plot? It's mainly designed to show us what? The what. I'll give you a hint. A box plot is designed to show us what? Here's your hint. What is a box plot designed to show us? The what? A box plot is designed to show us the 5-number summary. Charlie got some points right there. I love it. Good work. So if you look where, like, how much data is in this yellow area right there? How much data is in this blue area right here? How much data is in the yellow and how much data is in the blue? How much data is in the yellow and how much data is in the blue? Rotowave bomb! Good to see you, Rotowave. Watching on the TV, love it. I said 5,000. What's up, Rotowave? That's so crazy, man. I love it. It's like, if I ever, like, went by someone's room and I was like, oh, that's me. How much data is in the yellow and how much data is in the blue? Well, think, because it's the 5-number summary. It's going to be exactly 25% here and 25% here. So the closer these markers are, because the 5-number summary is all like markers of like the 0 percentile, the 25th, the 50th, the 75th, the 100th. So you can see the top 25% is more spread out. So the closer the lines are together. So how can you explain by looking at the box plot? It's going to be the areas in the box plot where the two are closest together or where the tallest bars are. Like these lines right here are closest. And so that's where the tallest bars are. Explain how both the histogram and box plot can indicate a distribution is skewed. Well, for the box plot, you're going to see more of a pole, like the quarters are going to get more further apart. The box plot indicates a skewed distribution because the min, the first Q, and the median occur within a small data range. It's talking about this. While the other ones, the median, the Q3, and the max, the median, the Q3, and the max go over a large data range. This diagram indicates a skewed distribution since the tallest bars are on the left side. Tallest bars are over here, and then it's right skew. Yeah, no, we didn't draw him. He's going to be sad if we don't do it. You know who it is. He's all sad here because we didn't draw him. But we got Monster Man here. Right to the high, left to the low, whatever way the Monster Man's tail goes. The high side, the positive side right there. So really good stuff. And then identify one feature of the distribution that the histogram shows but the box plot doesn't. It could be this slight bimodality. Remember, it shows shape better. The histogram shows the presence of... No, they both show outliers. The histogram shows that a very large number of values occur in the smallest bin. It's a maybe. The histogram shows the location of the median. No, box plot shows median. This term shows that the distribution is roughly uniform on the left side. No, we're going to go with this. I'm a little worried. It shows shape better. I mean, box plots can't show bins, so that's probably right. I define one thing the box plot shows. It shows the median, so we're just going to go with the median right there. Well, yeah, we got it right. A little worried, not about this one, because it shows median. The histogram does not show median. That one's a little weird, but that's got it. How's that look, Charlie? Do another one right here. We have another one from you. We've got a study reports load factors. A study reports load factors. A study reports. Here we go. These are tricky ones. They're all tricky, right? Every question is so tricky. A study reports load factors. Okay. A study reports load factors. And with this right here, the accompanying box plot displays the domestic load factor by year and all the domestic load factors. The box plots for each year shows the same data, but the outliers they show in each month is different. Why do you think this is? I think I got this one wrong last time I did it. It's because they're doing it as all the data, and then they're doing it by each month. So what looks common across, you see, what looks common month to month may stand out in the full data set. That's what I'm going to say. Outliers require context. Data values that may seem ordinary when placed against the entire data set may stand out when compared against one year to another, because those are years, not months. Like that value stands out. It's one way of saying it. Yeah, it's exactly what I did last time. Data values that seem ordinary when placed against 1 year's data may stand out when compared against the entire data set. It has to be this. I really don't like how they do that. This question, I'm glad we're doing it in the video. I showed I got it right in the video last time, and then the other time I got so like, there's just two ways of looking at this. I'm like seeing, are they specific enough? Because that point is not an outlier down here, but these points are not outliers up here. What I'm pointing to, and they're right, outliers are context dependent. But you could say, they really should have, it's a free question if you know the answer like we're seeing right here. Data points that are unusual year to year are not unusual. Do you see how this would be right there? Are not unusual. They're actually very close to normal, but that's unusual for that year. But in the entire data set, it's not unusual. Data points that occur in our full data set are not that unusual because that's the very low numbers right there for their respective years. So is something unusual? It requires context because you would say like, whoa, we were doing so horrible. But literally this data point right here at 67.5, that data point could be the start of our series and it could be about what we expected. You're like, yeah, that was a pretty common thing for that first year. That was what we would expect towards the median. And then you look over here, like in the first year, 82.5 would have been an insane outlier. So all data requires context. It's just a way of reversing it. Like things that are normal year to year might be unusual in the full data set. Things that are usual in the full data set might be unusual year to year. So I click that first one. Data values that are ordinary when placed against the entire data set may stand out. I should remember for next time because I keep double thinking because I got it wrong once. And I'm like, wait, is it the one I think it is or not the one I think it is? They're talking about these data points down here. Did they say like all those outliers? They really should say the outliers. Like for the massive amount of outliers, why do they exist? So for the massive amount of outliers, data values that seem ordinary when placed against 1 year's data, because you notice how they seem ordinary up here, like these points right here seem ordinary up here, may stand out when compared against the entire data set, which they do. Those points stand out in the entire data set, but up here, they're, yeah. So I should remember that next time. When we're talking about all the outliers, it should say, explain what's going on with all those outliers at the bottom of the graphic. It doesn't say that, does it? But the outliers they show is for a different month and year. Yeah, it should, yeah, it's just a weird question. It's a freebie though. I mean, if you see it, especially right here. I think they're kind of getting at it, and now I'm just second. I did this question for years, and I'm just getting it wrong. Let's do a few more while Brian's like, come on, Brian. Come on, Brian. Student in an intro stats class. I like the math ones. I had to get math wrong. A student in an intro. Where's the student? Oh. Is this the last one, Charlie? Do you have any others? Here are box of the points scored. One more, it looks like, right? Will that be your full quiz? Someone's going to be happy right here. They're going to be like, oh my gosh. Got my full quiz done. A student in an intro stats. There's 7. We almost got them all done. Okay. Here we are. Good to see Liz. Ask question, you got them. Student in intro stats course calculates the upper fence. Her maximum value is 17. Does she have an outlier? Well, is this point, when is something an outlier? The fence is what dictates outliers. So when you're doing a box plot, the fences are, oh, got a few more. The fences are 1.5 IQRs. Usually do it this way. You go 1.5 IQRs above. So they're saying the upper fence is here at 15.2. So you might have a whisker that goes to there. The whisker doesn't always go to the fence. But then there's a point over here at 17. So that is definitely an outlier. You might have the median and then your whisker down there. So it's definitely an outlier because it is beyond the upper fence. The fences denote where there's outliers. So that is what we got. And then we have, here are box plots of the points scored. So here are box plots of the points scored. Set to 1, chapter 4 quiz. Here are box plots of the points scored. Okay, here are box plots of the points scored. Drop some more questions if you got them. Gonna hang out for a little bit more, do some more work. Here we are. Here are box plots of the points scored. So you're looking at 2 different players right here. And with the 2 different players, the traveler one is, oof, oof. We're going to look at a bunch of pizza and eggs and stuff like that in a moment or whatever. Eggs and bread, I think. With this one right here, we're looking at 2 different players. Then we got Aaron and Kate. Wanna be Kate. It's a Ben Folds song. With this right here, what is the difference between these 2 players? What is the difference between these 2 players? The main difference in these players is a difference in their what and a difference in their what. Tell me 2 differences between these players. Once again, don't even look at their questions. Try to figure out what they're asking or what we know from this. Well, both players, the range and IQ, great job. Nice job. So you can see the range is smaller here, and there's the range. And then the IQR is smaller here and smaller here. They both have about the same, as far as we can tell, medians. So the medians are the same, but the range and the IQRs are much smaller. So both girls have about the same median, not IQR. Both girls have about the same median, but Aaron has a larger IQR. I believe that's right. Who should the coach pick? Well, here's the thing. Kate is going to be more consistent. Aaron is going to have greater potential. And it really depends on what the coach wants. That should be right. If it's the end of the game, you need points, you're going to pick Aaron. If it's the end of the game, you need someone consistent, you're going to pick Kate. So one has more variability. Aaron versus Kate is more stable. And yeah, it just depends on what you want. So yeah, that's the answer to a lot of statistics. It depends. Okay. Got to throw down my pen. Here are box plots of the point score. We did that one. And here is a histogram of the assets. Okay. 25, 23. Chapter 4 quiz. Here is a histogram of the assets. Okay. With this being a histogram of the assets, let's find it first. Here's a histogram of the assets in millions of dollars. Good, perfect timing. Of 79 companies, complete the parts below. Oof. Oof. This is extremely what? This is extremely what? I don't even look at the questions. Where we're going, we don't need questions. This is extremely what? What do we got going on right here? This distribution is extremely what? The distribution is extremely what? Ridiculously this. Insanely this. Crazily skewed. Unimodal and skewed to the right. Keegan, good answers right there. Got a crazy monster, man. So when we talk about the proper, we talk about shape, center, spread. So we need the proper metrics right here. Shape, center, spread. Well, shape is unimodal, extremely right skewed with outliers. And then we have the proper center is what? What's the proper center for this? The proper center will be what? You're only picking between two things. The proper center will be what? The median. And the proper spread is IQR. So let's do it. Okay. What is the aspect of the distribution makes it difficult to summarize? Crazily, most of the data is found on the far left. The distribution is very skewed to the right. Okay. What would you suggest doing with these data? You can take the logs or things. You don't want to square them. That'll make them bigger. Yeah, just log them. Kind of a weirdish question, like, because you could, like, log them to bring in extreme values. Kind of a more mathy type question, but, you know, not that bad. But very, very right skewed, and you could end up, like, logging the data. Okay, I think we only have the help travelers know what to expect, which I think that's a whole bunch inside of here. Yeah, there it is. I know where these are at. There's the pizza ones I was talking about. Okay. Well, there's the crowd crush ones. Those are fun. Let's do these questions. I'm going to click the answers and let's take a look. Because these ones can get really annoying with the way they describe them. Sometimes I cheat a little bit. Okay. So there's two versions of this. And to help travelers know what to expect. To help travelers know what to expect, they're looking at commodities in different countries. And which commodity is typically most expensive? We're not even going to look at their questions. Which commodity is typically most expensive? Which commodity is typically most expensive? Which commodity is typically most expensive? Which one's typically most expensive? Typically means measure of central tendency. Central tendency means mean or median. So which one is typically most expensive? Eggs. Yeah, nice job, Keegan. We'll trade some more points. Eggs is typically most expensive. There are some outliers in a bunch of these, but eggs are typically most expensive. And water has the lowest values, but let's take a look at what they ask. In average, which commodity is the most expensive? And like we just said, eggs are typically most expensive. The median price of eggs is higher than the upper quartile of bread and water. So that's the median right there. So they're pointing to this. There's just many ways to phrase it. I mean, it just has the highest median. We should have just said that. The highest median is eggs. And we're just going through it right there. And it's higher than these. It's higher than Q3 there and Q3 there. Just kind of making sure you know what those values are. These are prices from the same country, but can you tell whether eggs are more expensive than water in all countries? We can't really tell how these pair up because we don't know if this country's eggs is for this country's water or whatever. You can't tell whether eggs are more expensive than water in all countries. The prices overlap. So once again, you don't know if like maybe this country's water, like if there's a point there, goes with this country's eggs. So we can't exactly know the one-to-one comparison. Not my favorite way of asking the question. Here, we'll do the next one here too. In general, which commodity is the most expensive? Once again, it's eggs. Is a carton of eggs always more expensive than a bottle of water? And the answer is, and this doesn't say like for each country. It's just like, is it always? So is a carton of eggs always more expensive than a bottle of water? How are they? I always think this one's the weird one. Some of the water prices are above the minimum price of egg cartons. So just the way they phrase it, they're saying, is it always more expensive? No, but it's not saying like in a country. It's just saying, is every egg price above every water price? And no, you do have prices down below. So it's just a weirder way of asking. It's not asking like in the countries you go to, because this one is like in all countries. That's the key right here. You can't tell by the country breakdown. But here, is it always the case that eggs are more expensive than water if you just look at prices and say, man, eggs everywhere are more expensive than water? No, you could find cheaper water, and it's priced in US dollars. So make sure it's on the same standard right there. Well, that's got that one. What else do we have? Do we have any other questions? We've gone for a little over 30 minutes, but I think, Charlie, did you get a good grade, or did you do all right? I want to come up and do a little bit of office hours today because I had to. Oh, man. Yeah. 96. No, that's awesome, Charlie. I say, yeah, let's go. Looking at a text right there. Yeah. Better than my. No, Keegan, which ones do you want us to do? Which ones do you want us to do, Keegan? An organization provides. Let's do that one. Let's do a few more. We still got some energy, right? We still got some energy. There was question 2. I put the answer you said to do. Which one? I'm gonna look at that real quick, and then we're gonna do this other one. Let me go to the main screen. Some pull up grades. Liz, we got that question next here. I'm like, oh, I'm so tired. I'm gonna take a look. Who's the opposites? No. Double check. I think you might have misclicked, Charlie. I think you might have misclicked. Yeah. Double check. Yeah. In a way, box plots are the opposite. Yeah. Oh, the rain, no rain. That one's tricky. An organization provides. Let me go. Great work, Charlie. You got this. Or if you want to redo it. But really great work. Getting high 90s on these is awesome. So everyone, give some 5,000 points for Charlie right here. Really good work. Starting these early, getting them done. I mean, this isn't even due for a little bit right here. It's not due till Thursday. So getting it done now, you're like, done with it. Let's do the Chapter 3 quiz and organization provides. Thank you so much, Liz, right there. Let's go do it. If you have some more questions, put them on here quick so we can find them. And organization provides. An organization. I turned off the music, right? I did. Okay, I haven't done this one in a while. Ooh, new question for me for first little bit. Stat 201, chapter for quiz. My wife made banana bread muffins. They're so good. I have a problem. I went home and ate 3 yesterday. Because they're good. I'm sorry. Okay. So we've got data on women 18 through 24 and men that smoke. So if you look right here, this is a table with 3 variables. You have men, you have women, you have age, you have year. And when you think about it, you look who smokes. Who's the smokers? Well, the smokers are definitely in here. It's going to be men my age, because I'm 25, in the 80s. 80s men are smoking. So now we look, and these rates are decreasing. As you go forward in time, they're decreasing. If you look at women counterparts, they also decrease. And if you look at age group, it kind of peaks around the 30-year-olds or so. That's where we see more smokers. The same-ish trend for women. Younger women are smoking more often. It's don't smoke, don't vape. Personal opinions with Brian. Let's check this out. The trends with time are in the same direction, as in men and women are smoking less. Both men and women, as we increase in time, are smoking less. So they're in the same direction. And the rates for women are lower, generally lower than the rates for men in each year. Relatively fewer women over the age of 65 are smoking. What might be, what variable might affect this? Wow. Trying to remember this one. Shouldn't be this complicated. Is it saying another variable? What other variable? So it's actually asking like another variable outside of this. And so if it's asking another variable, it's probably whether or not they have children, because that'd be another variable. The other ones really aren't other variables. Like overall smoking rate is not something you'd collect on women. When it says a variable, it'd be something about the individuals. Like we talked about the 5 whys to begin with. That's just that's a parameter. This is a variable you could collect on women. That's just another parameter, like meaning some truth for the population. So the only one that made sense to me, and I haven't done this one in a while, is it should just say which one of these is a variable we could collect on these women. The other things aren't variables; they're population parameters, facts about the population. Any other ones? You're welcome, Liz. Good question. Got me thinking. I was worried for a moment. I was like, what do they want? It's the subjective ones that are tough. It's the subjective. And I think you can see how both are trending downward. And generally, women are less than men. You can see, like, here, men are smoking less as time goes on, from young men, 42% to down to 29, 25, 18. Now they got to do 2024 in this table. Question needs an update. Any others? Last questions? Any others? Oh. We got to get a bit of work done. I always hope these videos can help people out. We got all these questions. You know what? We got to finish off the homework. We got to do that. Let's finish off the homework. And then if someone asks, I can say, we did all the homework. We got to do it. We got to do it. We're here. We're here. Ready to do the homework. Question 3. And if anyone else has any other questions, let me know. Each question we do gives me more energy. The quiz, the histogram, and summary statistics? Yeah, tell me the start of it. We'll do that one right after the homework. Okay. Chapter 4, homework. Oh, we did load factors. Watch, I'm going to get it this time without cheating. 3rd time's a charm. Okay. So, first time ever doing this question, ever. Haven't been doing it for years, and I've never missed it. Totally going to get it right. Okay. Question 3. So there's a study about load factors right here, and we're looking at not the graphic I expected to see. These are side-by-side box plots. Side-by-side box plots are the visualization of a categorical X with a quantitative Y. So a categorical X and a quantitative Y are being shown to you in side-by-side box plots right there, categorical X, quantitative Y. And with this, you can see some extreme outliers here in March and April, also an extreme outlier. I mean, it's pretty large. Extreme is highlighted by a star. And we see a pattern to this where it goes like that. It's kind of the series in it, the trend of it. So cool stuff. Load factors are generally highest in the... That's August, September, yeah. August, September months. So probably, no, June, July. September's about the end of it. Yeah, it dips down towards September. So that should be right. Whatever the other thing is, yep. There we go. There are lower values and more variability in the winter, spring, and you can just see your highest right there. It's got to know your months. August is there, and June is there. So that gave the answer away. Just tried to find the peak in the series. And when we say typical, we are talking about the medians in the box plot. So you want to look at the medians to see what is typical versus not typical. Was that it? That was it. Okay, we're almost done. People are like, the homework's so easy, Brian. The homework is too easy. Please put more difficult questions on this assignment. Okay. Which of the following is a true statement about box plots? The center of the box plot shows the middle half of the data. The center of the box plot shows the middle half of the data. Oh, yeah, wait. The center of a box. I think it's talking about the box of a box. Oh, it's a box. I can't read. The center of the box plot is a box that shows the middle half of the data, known as the IQR. The center of the box plot is a box that shows you the middle half of the data, or the middle 50%. So that's the IQR right there. The IQR. Next, we have box plots are great for comparing two or multiple groups. Oh, yeah, they are, side by side. The values which are displayed by a dot or an asterisk are outliers. If it's an asterisk, it's an extreme outlier. A dot is just an outlier. They can be the min or the max. The center line of the box plot signifies the median. You bet it does, the median of each group. So that's it. Every one of those is a facts about box plot. Also, box plots show you the 5-number summary. One more question. This is it. Is this the, not the load factors, right? Is this the, oh, same graphic, but different question. Sometimes they reuse it. And we got Charlie's question. Okay, 41, 23, stat to a 1. Okay. So what we have right here is some box plots side by side with an aberration in month 15, or year 15, excuse me, 2015. These are the years with just the last number beside them. The series has been generally going up, and outliers are context dependent. So what we have right here is air travel after extraordinary events was not typical of travel in general. In order to analyze monthly patterns, it might be best to leave these data. What's this asking? Do you think the data for months affected by extraordinary weather events should be set aside in the overall analysis of load factors? Air travel after extraordinary weather events was not typical. I don't know how we're seeing that of weather travel in general. In order to analyze monthly patterns, it might be best to leave these days in. It might be best to set these days aside. It's talking about dealing with outliers. That's just such a weird. This question is just about outliers. That's all this question is about. This question is like, if you have outliers, what might you do with them? And if we're trying to understand what typically occurs with air travel, if you have some sort of like blizzard that overtakes the United States, and you're like, well, what should we expect in January? And we're like, well, last January there was a blizzard. Be like, okay, well, let's not base our predictions off of last January. Let's kind of exclude that data for the moment and understand that's what happens when there's an extreme weather event. And we could use that data to predict extreme weather events. That's not like a January model for us. So that's what they're talking about right here is, since it's so not typical, you wouldn't predict monthly what's going to happen, like January's expected values based on the January where you had the blizzard. So it's saying like if you get extreme outliers that do not conform and have some other problem with them, like they're due to, blizzard, well, then you're not really predicting January anymore. You're predicting a blizzard. Now, of course, you want to understand that outliers also always get special attention. So that was a little tricky. More of an outlier question. That's all the question was. We didn't even need to see those box plots. They're trying to trick me with box plots. Chapter 4 quiz, the histogram and summary statistics. The histogram and summary statistics. Okay. Oh, we haven't done that one lately. That one catches people. There's a trick to it. I'm shocked we haven't. Well, we'll probably do it coming up here. Ooh, this is a tricky one. This one catches people. This might be one of our last questions here. But this one's a good one, Charlie. This one catches people. The center, yeah, that'll be our last one, Liz. We'll do that one last to finish. And the histogram and summary. Okay. Here we go. So we have the necessary components for the 5-number summary over here to draw a box plot, which they'll have us do down below. So because the distribution is skewed to the right, very skewed, what should we use? Well, center is either going to be median or mean. But because it's so heavily skewed, you got this, Charlie. You got this. And I'll show you a trick on the channel, and message on the Discord if you're stuck on one. But if you're on the channel right here, I'll show you a trick because I'm gonna head home and get some food here soon. If you type in I'm gonna do your question too, Liz. But if you type in centers for disease, the way I mark these questions, you can find usually where I've done the questions, like the Center for Disease Control right here. So you can see, you can usually find them if you go through. But I'm gonna do the question here because I like doing them live. I want people to ask questions. The biggest thing to me is interacting. But usually if you put in those first few words, I started doing that, and then you can actually find them. But if you can't find yours, Charlie, let me know. But no, good work working on this. So this is a heavily skewed distribution, and because it's skewed, we're going to use the median, and then for the center, and then the spread is going to be the IQR. Those are what are properly paired together. Now, to figure out how many outliers there are, we need to figure out where the upper fence is. This is a good quiz question. How many IQRs above Q3 is where the upper fence is? How many IQRs above Q3 is where the upper fence is? So this is the IQR, which is 50. How many IQRs would you do? You go IQR times what? IQR times, remember this number? 1.5. So you take 50 times 75, and you go to where 78 is at, and you go 1.5 IQRs above, which is going to be 78 plus 75, and with this 1.75 times, oh my gosh, I think I miswrote because I was doing the math already. Is this making sense, Charlie, right here? You take 50, which is the IQR. I wrote it down there. 50 is the IQR, and you times it by 1.5, and you get 75. So then you take Q3, and you add to it the 1.5 IQRs. And that's what I'm doing over here visually, and you land right about here. So how many blocks are beyond this? 1, 2, 3, maybe 4, 5. So it's hard to tell, but there's maybe 3 to 5 outliers. It's hard to tell if this fence right here, where the outliers begin and end. So there's maybe 3 to 5 outliers, so it must be answer A or C. And if we look, it's because of the 1.5 IQRs above Q3, which is what we were drawing out here mathematically to figure out where the upper fence would be. So now we look, which ones have 3 to 5 outliers? Well, if you look, there's an outlier at about 275 or so. So it has to be this one or this one. It has to be one of these two answers because these don't have this high outlier. So knowing it has to be one of those two answers, we can take a look at this one. The median on this is close to, I think that could be 43, the median. What's the median on this one look like? It's also about 43. But the Q1, is that 28? That could be 28. Ooh, does this Q1 look to be a third the way up? Yes or no in the chat. Do you see where Q1 is at? Does that look to be a third the way up this? Because this should be at 28, which is over a third up it. Does that look right or wrong? Does it look prospectively? So here's the thing. 28 is a third the way up this. If you think 1/3, that's not even like a quarter up this. Does that make sense? So I don't think that's like, does that make sense? It's not even like, if that's where 28 is at, this would be like 56. And then this would be, you see, it's too small. Don't worry, Keegan. This is a tough one visually. The other one, if we ask, yeah, it could be 20. It could be 20. Let me ask on this one. And why am I writing 28? Here, I'll include this on the screen. Do you see where it says Q1 is 28? So over there on the far side, it says Q1 is 28. So do you think that is a little over a third the way up? Does that look better where 28 would be at? Like, do you think that could be 28? Like, if I go from Q1 to the left, do you think that over there is where 28 could be on the scale over here? Like, does that look about... I'd say it looks better. It's higher up than the last one. So, and I might have dropped my bar down a little bit. Yeah, roughly, yeah. So it's this one right here. And then you can see the 3 to 5 outliers. There's 4 outliers, and that's where the fence is at. Really, you're just looking where the Q1 is at. So the proper Q1 is a little higher. It's a little tricky, but where the Q1 is at. This one, cross your fingers, everyone. The distribution of number of campsites at the parks of Vermont is, it's pretty much unimodal. Pretty sure it's got that one bump right there. And it's definitely skewed to the right. The distribution, the center of the distribution is approximately, which is where the median's at, 43.5. So it's the rounding. The distribution of campsites is, I think they're going to say quite spread out. These peaks have in excess of, and this is where we have to do the upper fence. Remember where we calculate our upper fence? We should get 100. Got worried. This is the upper fence because they have above 153. That's where we did 1.5 times this. So we found out where the upper fence was at. So you have to follow through this. I wish I could pull back up and show you where I did the calculations, but go through the steps right here, quite spread out because they go from 0 to 300 or 0 to 275. And the hard part usually is picking out this box plot. You can narrow it down to between these two because of this outlier is not included in those. And then you can look for the small differences. I guess there is data knowing, I guess it's usually this one where the fence goes right up to it. Well, we'd have to see if that's that point right there. They might be saying that, oh, no, there's an easier way. There's an easier way because there should be 5 dots. There should be 1, 2, 3, 4 dots here. And I mean, there's 4 dots, but there should be 5. And this is showing you that that point right there, one of those 2 dots, because there's 2 dots there, because it has a bin height of 2, one of those 2 is not an outlier. But if it was an outlier, there should be 5 dots. So that's another way to deduce it because this shows that the lowest one of those right there is not an outlier. So good stuff. Yeah, that's a tricky one. In years past, I used to maybe make a mistake on that one. That's why I always get worried on that one. I'm like, oh, any problem I've ever gotten wrong once, there stands a chance I'll get it wrong again because I'll overthink it. I'll be like, but wait a minute. One time I answered it completely different. Liz, you got the last question of the day here, the Center for Disease Control. Medical researchers. We'll be doing that 5th grader question one of these days. Here it is. This one's all about some side-by-side pie charts. Look at this. We got a whole bunch of work done. Almost an hour. Thank you, everyone, for being here. I felt bad that we didn't really do office hours much this morning, so I was like, I need to come back and do some more. Okie dokie. So when you're looking at this data right here, you have to think, how is each one broken down? So in the first one right here, we're going to use the graphical displays to do the 3 groups. Let's do the normal group. Well, in the normal group, the most common thing right here is going to be regular, not intense, which regular, not intense is green. So it looks like it's going to be A or D. And with it being A or D, we look for small differences now. The second biggest group needs to be irregular activity. And see, the problem is that about a quarter? It is about a quarter. Look, inactive is not more than a quarter, and blue right there is more than a quarter. You see, I'm looking at this and being like, because I narrowed it down to these 2, I believe, because the regular intense was the biggest. And then this is more than a quarter, but it's not more than a quarter, so it has to be over here. It's all a perspective thing. And what do we here? Are the percentages in column, row, or table percentages? They're going to be in column percentages. If you look at the way this is done, because all the columns add up to 100, so it's the column percentage. It's like given someone has an old BMI, given someone is overweight, given someone is obese, right there. So let's go to the next one. Okay. So on this next one right here, we see the highest group for overweight is going to be, well, we go to the lowest, the regular intense. It's going to be a very small yellow. So that narrows it down to B and C right there. So between B and C, is inactive about a quarter again? It's a little more than a quarter, and that looks way more than a quarter. So looking at this right here, this one is a little bit more than a quarter, and that's way more than a quarter. That's very close to a quarter, and that's very close to a quarter, but a tiny bit more. So it does appear to be C. A little tricky. And the last one right here is going to be the obese. Once again, the yellow is the smallest, which means because yellow is regular intense, which is the smallest. So we've narrowed it down to these 2 right here. And now we have to think, okay, the blue is going to be the inactive. Oh my gosh, 35%. See, that's a little bit more than a quarter, and that's way more than a quarter over here. And then the green and the red should be almost similar, which is the 2 middle ones, right? And they are very similar as the 28 and 27. So we should have it. And then there's one last thing. Do these data prove? Remember when we talked about prove in class? That's a bad word. We don't prove things here in stats. The data provide evidence that there is no association. Let's see, the data provided evidence that the lack of exercise and obesity are not independent, but it could be that obesity causes lack of exercise or another variable. Yeah, there is a relationship here. Let's look at the table again. It's generally, you see that the normal people, normal, whatever that means, normal BMI, normal percent body mass index, have more people doing the regular intense exercise versus the obese have more inactive people. So there is an association. The data provide evidence that they are not independent, evidence of an association, but we can't say prove. So you cannot say prove with these things. You can't say we've proven that there's that we've proven that they're related. We just have evidence of an association. Does that make sense? So that's got it. Went for right at an hour. But any last questions or comments? I didn't drink a Red Bull today. I did it. I went no Red Bull. No Red Bull. We did it. Trying to get back. Like, I don't know. It's like you get addicted to caffeine, I think. I think I got that problem. Nope. Doing well. With that, we're going to head on out. Till then, bye for now, everyone. Bye.